Good day everyone. So today we will going to tackle about the Fibonacci sequence, the sunflower patterns, rabbit growth, and the golden ratio. Objectives. By the end of the 45-minute lesson, learners will able to demonstrate understanding of mathematical patterns, sequence, and the real-world applications, including growth, nature, and proportions. Analyze, describe, and explain number patterns and sequences, including Fibonacci numbers in real-life contexts such as plants, animals, and arts, and describe, explain, and apply Fibonacci numbers in natural patterns and real-world problems like plant spirals, animal population growth, and the golden ratio. Look at this sunflower. Do you notice how the seeds form spirals? Check out this seashell. Doesn't it curl in such a perfect and beautiful way? And the rabbit, see how pairs grow over time. Finally, this golden spiral, notice how it appears in art and nature. Now tell me, have you ever noticed patterns like this in nature? And why do you think some things just look so naturally pleasing? What makes them beautiful? Here's the interesting part. All these patterns, the spirals in sunflowers and shells, the way population grow, and even the way artists design things, they all have something in common. It's a mathematical pattern called the Fibonacci sequence. It's very simple. You start with 1 and 1, and every number after that is the sum of the two numbers before it. So for the sequence example, we have 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. So we start with 1 plus 1 equals 2, then 1 plus 2 equals 3, then 2 plus 3 equals 5, and so on. This pattern appears in nature, animals, and art. And we're going to explore how this pattern works and where we can see it in real life. So we have the sunflower seeds. We observe that if you look the center of the sunflower, you'll see seeds arranged in spirals that go both clockwise and counterclockwise. What is the connection to Fibonacci? Count the number of spirals and you'll often get the Fibonacci numbers like 34 or 55. Why it happens? Because this arrangement lets the sunflower pack the maximum number of the seeds without leaving gaps, making it very efficient. So, the sunflower uses math to grow as many seeds as possible in a small space, and the pattern flowers follows Fibonacci numbers. So rabbit pairs population growth. So Fibonacci originally imagined pairs of rabbits reproducing month by month. What is the connection to Fibonacci? The numbers of rabbits pairs each month follows the Fibonacci sequence. Month 1, 1 pair. Month 2, 1 pair. Month 3, 2 pairs. Month 4, 3 pairs. Month 5, 5 pairs. Why it happens? Because each month's total is the sum of the 2 previous months, which shows how populations can grow according to patterns in nature. So, Fibonacci used rabbits to show how population growth, and it turns out the numbers follow a neat pattern. The shell spirals. We observe that many shells, like snail shells or nautilus shells, grow in a spiral shape. So what's the connection to Fibonacci? The spiral roughly follows the Fibonacci sequence or the golden spiral, meaning the curve expands in proportion according to Fibonacci numbers. So why it happens? Because this shape allows the shell to grow without changing its shape, keeping the spiral proportional as it gets bigger. So as the shell grows, it keeps the same spiral shape, and the math behind it is the Fibonacci sequence. Now, let's see how Fibonacci first discovered his famous sequence. If you start with one pair of rabbits and every month each pair produces another pair, how many rabbits will there be after several months? So, let's count month by month. So, in month 1, we have one pair of rabbits. In month 2, one pair because the first pair hasn't reproduced yet. In month 3, we have 2 pairs. In month 4, we have 3 pairs. In month 5, we have 5 pairs, and month 6, we have 8 pairs. Notice the pattern. Each month, the total number of pairs is the sum of the 2 previous months. That's the Fibonacci sequence in action. So this is Leonardo Fibonacci. So how did Fibonacci use rabbits to discover a number pattern? So Fibonacci used a simple problem about rabbits to explore how population grow. He imagined starting with one pair of rabbits and assumed that each pair produces a new pair every month. By counting month by month, he noticed a pattern. Each month's total number of rabbit pairs is the sum of the previous 2 months. This pattern became known as the Fibonacci sequence, showing that numbers in nature often follow predictable patterns. So we have the Fibonacci in sunflowers. So sunflower seeds from spirals in 2 directions, where we count the spirals, often Fibonacci numbers 34, 55, 89, and the patterns help pack seeds efficiently without gaps. So look closely at the center of this sunflower. Do you see how the seeds form spirals going in 2 directions, clockwise and counterclockwise? If we count these spirals, we often get Fibonacci numbers like 34 or 55. Why does this happen? Because nature is smart. The sunflower arranges its seeds this way to fit as many seeds as possible without leaving empty spaces. This is called efficient packing, and it's one of the ways math appears naturally in the world. So, the next time you see a sunflower, remember, the beautiful pattern of its seed is actually math in action. Now, let's explore something even more amazing. Fibonacci and the golden ratio. The golden ratio represents by the Greek letter P, which is approximately 1.6818. So here's a fun question. If we divide consecutive Fibonacci numbers, the result gets closer and closer to pi. For example, we divide 21 divided by 13 is equal to 1.615, and also 34 divided by 21 is equal to 1.619. This ratio is not just a number, it appears everywhere. Look at this example. Shells like the Nautilus shell grow in a golden spiral. Galaxies form spirals following this ratio, and pine cones show spiral patterns in their scales. Human creations like architecture and art often use the golden ratio for balance and beauty. Now, think about your surroundings. Can you spot the golden ratio in things around you? This shows that Fibonacci numbers and the golden ratio are not just math concepts, they're patterns that connect nature, art, and the universe. So this is the summary of the Fibonacci sequence, sunflower patterns, rabbit growth, and the golden ratio. So in sequence starts 1, 1, 2, 3, 5, and 8, and so on. Each number is the sum of the previous two, forming a simple pattern that appears in many places in nature. And the rabbit problem, where Fibonacci imagined rabbit pairs multiply each month and notice the number of pairs follow this sequence. The sunflowers, which is the seeds in sunflowers, grow in spirals that often match Fibonacci numbers, allowing the plant to fit as many seeds as possible. And the golden ratio, which is pi is equal to 1.618, dividing consecutive Fibonacci numbers gives a value close to the golden ratio, which appears in nature and human design. And also, that appears in nature, animals, art, architecture, and galaxies. Fibonacci numbers and the golden ratio are found everywhere, from shells and flowers to buildings, paintings, and even galaxies. Shows it and it also shows math is everywhere and help explain patterns and beauty in the world. This sequence shows us that math is not just numbers. It explains pattern growth and the beauty we see around us. In conclusion, Fibonacci numbers and the golden ratio shows that math is everywhere, from nature to art, and all help us see patterns and beauty in the world. Thank you.